Hello students, welcome back, and from this lecture onward we are starting a new topic, that's our work, energy and power. Okay, yes, so without wasting time, let's start this topic. Three main things we will learning in this chapter: work, energy and power, and the relation between them. Okay, yes. Okay, first we starting with first word itself, work. Very simple term. All of you already know what's the meaning of work and few basic things about them, right? Okay. So work, suppose a body is there and some force is acting on the body, and that force can displace that body, means when the force is acting and the body start moving, correct na? Then we said that that force is doing some work on that body. So in mathematics how they say that, let me write in short definition, that whenever a force acting on a body, it should displace the body, right? Displaces it. Work is done by that force. Correct. Whenever force is acting and that force also what it doing? It displacing the body. Suppose body is not displaced, then there will no work done. That we will talk little later. Okay. So whenever force is acting and displacing the body, correct, then the work is what? Done by that force, right? Okay. This is a very simple thing. Now look here, how work is done, how we define mathematically. First we say here, like there may be 2-3 type of forces, like the force acting on the body may be constant or maybe varying with time or distance, right? So look here, first type things we talk, work done by a constant force. Okay. If you want to add one more term here in definition, that mathematically, like I said, when a force is acting and displacing the body, work it is done, right? Or in mathematics, how they say, in maths, mathematically you say, right, that the scalar product of force and displacement is called what? Work. This is your mathematical definition, right? No? That's general how you say that force is acting on body, displacing, then we call work is done by the body. Then what is formula or what's mass definition? The scalar product of force and the displacement is called what? Simply work, right? Okay. So this will be more clear here. Work done by a constant force. When force is constant, and what is the work done? Simply the scalar product. So you say by constant, how you say work done is equal to F dot S and cos theta. You can write like this way also. Okay, I'll write that vector form separately. So this is what force, let me write all these things. F is the, okay, doesn't matter, F is the force and your S is the displacement of the body. Displacement, keep in mind very important word, displacement, not distance, because you're talking vector things, okay. Yes, so this is a displacement, not distance, okay. Yes, displacement is S and this is your angle between F and S, that we calling what? Your theta. These are three things coming here, okay. The scalar form Fs cos theta. Now it's very important to understand that this theta, this cos theta is angle between what? Force and displacement, right? So suppose this is the direction of displacement and the force acting on the body like this one, and this angle is given what? Theta. Correct. You want to calculate what is the work done by this body. What you say? Either you say what like this way. You take the component of force along the direction of our displacement. Right now? You take the component of force along the direction of displacement. So if you take the component of this F along that direction, this becomes simply F cos theta, right? So what is the work done? You say F cos theta into what? S, or Fs cos theta, right one? Or you can say opposite also. You take the component of displacement along the force direction. If you take the component of displacement along that direction, means this component of displacement become what? S cos theta. So what is the work done now again? You say the F, force is F and component became what? S cos theta. The same thing, only Fs cos theta. So what people say, if you know angle between force and displacement, simply you can put in formula itself, or by definition what they are saying, what is this work done? you take the component, either you take the component of force along the direction of displacement or component of displacement along the direction of force. That's what your work done, right? So, okay, we will do once I teach the basics for like what type of works are there, the work done by constant force or variable force, then I will do problems on this. You will understand what's the use of these formulas, okay? Okay, so this formula you can write in vector form also. Let's write in vector form, because many times they have asked in our exam vector form. So I will write simply, already say it's a scalar product of what, force and displacement. So work will be simply equal to F dot as. That's what simple answer, vector form, right? Dot product of force and displacement, right? These are two vectors we give attention. Force is a vector, displacement is a vector. When two vectors you multiply by dot product, answer is what? A scalar. So your work done is a scalar property, right? So this is not a vector. This is what? Scalar. Force and these things, you know, these are what? Vector. Okay. And displacement also what? Your vector. Right. Two vector you multiply by dot product, what you will get? A scalar value always. Okay. Always. And this basics of this vector multiplication, hope you may remember, right? Dot product and what? Cross product. If you don't know, in brief I am telling here, because we now onward we need in this chapter, okay? So if you talk about dot product, then what is the answer? If you multiply two vectors by same, like you said, I vector dot I vector, your answer is what? 1. J dot J, right? Answer is what? 1. K dot K. Similar means answer becomes 1. And if you have anything opposite like I dot J, that becomes 0. You can say I dot K, 0. Any combination, okay? J dot K, right? All this becomes what? 0. That's a dot product, okay? Yeah. Same way we have cross product also. If you want to learn what is cross product, I will teach separately these all this. Cross product are also called vector product. That's called dot, or also called what? Scalar product. Here, after answer we get always a numerical answer, right? As value simply magnitude. Here we will get what? A vector answer again. So what's the rule here? Like when you multiply I dot J, what is the answer? So simple cycle is there, I, J and K, this cycle. This cycle goes like this way, clockwise. So if you multiply like I cross J vector, what is the answer? Next, K vector. I cross J, the cycle is going like that way, keep in mind. That's a positive cycle we say. Yes. I cross J, answer is what? K. You write J cross K, answer is what? I vector. Or you multiply K cross I, answer is what? Your J vector. If you go opposite, reverse, then these answers are only negative. Suppose I write I cross J, write J cross I, opposite, then just become what? Sorry, J cross what? I minus K, right? Hope these things already know. You write opposite like K cross J. You go like K cross J, then is what? Minus I. Okay, all this we can write, and similar thing here directly becomes what? 0. Means suppose you write somewhere that I cross I, similar direction, directly what? 0. J cross J, that's 0. K cross K, right? That's what? 0. Simply, okay? So this cycle only you have to follow for cross product, okay? So in this chapter we need dot product only mainly, okay? Yes. Next chapter when we learn rotation chapter, we need both things. Mainly we need what? This. So we'll talk about them that. So first I am saying work done. How many ways they can ask? First is what? Work done by constant force. Simply this formula you have to write, okay? Fs cos theta. Or in vector form, then F dot S, vector form. I will give example of each and every pattern, okay? Once I tell you the basic. This is in vector form. Then next will be what? In work done by a variable force, okay? Work done by a variable force. What's the difference between this and this? This vector form is easily to identify that what is vector form. Here, work done is constant, some value will be given like a constant for 16 Newton is acting. Okay. Here, variable means an equation will be given to you. So whenever variable things is there in physics, either you have to do integration or what? You have to do differentiation. There are only two possibilities we have. Okay. So work done by variable force. If force is variable, force is given in terms of what? Displacement, some equation will be given, like they say force is very 3x square plus 5x, something is given to you. Then what you have to do? Always you have to do integration or differentiation. So here we will do what? Integration. So in that case, work done will be what? Simply equal to what? Integration of f dot what? Dx. Some range will be given for 0 to x for x displacement, okay? Yes. This is what the work done. Correct? Yes. In real they are also vector only, but we write like that way. You can write this way, or simple you can write f dx, still no problem. Okay. So this is what? Work done by variable force. When force is variable, we have to do what? Integration to find the work done by that body. In displacing from, they can give anything like better y always 0, initial displacement x1 to final displacement x2. Okay, anything can be given to you, no problem. Okay, these are the limits we can put once we integrate. This like when understand is important. Again, in variable force they can ask for in two ways, and how they can ask, you will write like this way. If this only like one coordinate is given, suppose I say the force is given by, I write somewhere 3x square plus 10x plus 5 something, right? Now this is given. So force varies along in what? X direction alone. So this much is the only answer, right? But suppose x and y like this same is given like that way, 3x square y plus 10 y square z something, right? 2 variable, 3 variable, all these are given. Then we write same formula in terms of what? Cartesian form, right? Now, so in Cartesian form, how it looks when multiple are there. Okay. What will answer? Net work done will be simply equal to what? Look here, f dot dx. Okay, here f force in x direction into what? Dx. Okay, range you put x1 to x2 plus force in what? Y direction into what? Dy, y1 to y2 plus fz into dz, z1 to what? Z2. Like this you have to do. Okay. Yes, when multiple or, so in that case how you will do, I will give example also, and these are very important because similar things are comes in physics everywhere, okay. Yes. So look here, suppose this is given is a very easy, with respect to x only you have to integrate that much only. If this is given, then suppose when you integrate with respect to x, then y and z you have to keep constant. Then when you are doing with respect to y, then x and z you have to keep constant. Same way you have to follow. So I will give example for this, you will understand better there. Okay. So, okay, work done by variable force, like single coordinate is varying or multiple, which we write in Cartesian form. Okay. Next we can write work done in terms of what? Graph also, right? Work done by graph, okay. Suppose graphical way also they ask, many times they have asked. So how they ask graphical? If you draw a graph between what? Force and displacement. This side is force, displacement. Then you show that the area under the force and displacement curve, if you calculate the area, that gives simply work done by that force. What it gives? Work done by the force. If you calculate area under what? Force and time. So write it carefully. That area under a force and time curve gives what? Work done by that cycle. Also give attention, suppose positive quadrant, then positive work done. If you have some graph in negative quadrant, then this work will be positive, right? Let it write here like this work is what? Positive work. Then this work will be what? Negative work, right? Now, so because work is scalar, so algebraically you have to add this positive, negative, right? Calculate the area of this part, calculate area of this part, add them algebraically, positive, negative, right? That gives what? Net work done in that curve, okay? Okay, so 4 ways. Once more, constant force, again vector form, variable force, one coordinate, multiple coordinate, or work graph. These are the 4 ways to ask the direct questions on what? Work alone. Mainly they relate with next thing, energy and power, all these things, but we will do that later. But if they are asking any question directly alone on work, then these are the ways to ask, okay. Few extra things we will talk here. Okay, first we talk like when work is positive and when work is what? Negative, okay. Positive and negative work we talk. So work done will be positive. Positive when? Then you can understand from here. Suppose this angle cos theta, you put 0 degree, smallest angle, then this becomes simply f into s, right? Then you keep increasing angle. This theta is increasing, work will be decreasing till 90, it becomes what? 0, correct? Now, if this angle is more than 90, then you show that cos term becomes what? Negative, right? Suppose I say cos angle is what, 120, then you write minus 1 by 2, right now. So this term start getting negative, the work done becomes what, negative. So work done is positive till what, angle is what, 0 to what, 90 degree, right now. Or you say that the body is displacing in the direction of the force. You are applying force in like this direction and body also being the same direction, then the work will be what, positive. So two ways to say. One way is saying if your theta is between 0 to what, 90 degree, okay, or less than 90, you can say simply less than 90, because at 90 it becomes what, 0. Your theta is what, you say theta is, okay, let me say more properly, your theta should be what, less than 90, more than 0, and less than what, 90 degree. In that case, work done will be positive. Or simply you say in word, then you want to say that if body displaces or moves in the direction of force, right, then this work is called what, positive. If body is moving in the direction of the force, then work done will be called positive. Let's talk example. Suppose you drop a ball, freely you drop a ball will fall toward the earth, right now. So then they ask, what is the work done by gravitational force? Then this work done will be what, positive. Why? Because the force on this ball is acting what, downward, and ball also moving what, downward. So the force and displacement are in same direction. So work done by gravity will be what, positive, right now. So example is saying, then I can say what is the example, like work done by gravity on a freely falling body, right now. Okay, so work done by gravitational force, when you drop a body simply, then the work done will be positive, because the force, gravitational force is acting downward toward the center of the earth, and the displacement of the body also towards the center of the earth, right. Okay, so angle between them is 0 degree, they will say, because same direction, right. Okay, other example you want to see, then the spring force, you say that force applied to a spring. You have a spring and you want to stretch it or you want to compress it, then you need to apply a force. Then what is the work done by that force here? Suppose this is your spring and this is the natural length. Now you want to expand it, so you apply a force in this direction, right? Force in that, then you know initially this was here, then spring will expand and look like that way. So expansion is happening in this direction, right? So displacement or x we call that also in that direction, right? So this external force we have applied and this is displacement, they are in the same direction. So work done by spring force also what, positive, right now. Suppose you compress this, then you apply force in that direction, then spring will compress in same direction, right? Displacement of the spring will be in same direction again, right? So again the work done will be positive, right? But you see, this is work done by what, external force. But if they ask work done by the spring force always opposite to the force you are applying. So I will talk here in second point. Okay, work is negative. Let's talk negative work. Okay, work done will be negative. When the work is done negative, first you say in terms of angle, if theta is more than what, 90 degree, but less than what, we should say like this one. Okay, 180, like this range. Okay, yes, more than 90 but less than 180, theta will be negative. So work done will be negative. Or you say that body displaces in a direction opposite to what, force. Force and displacement are what, in opposite direction. In that case the work done by the body will be, or that force will be what, negative. Let's say example, most famous example is your friction force. Friction is always opposing force. You try to stop a body, right? Suppose your body is moving that direction, right now, body is moving that direction, the velocity or displacement of the body, then this friction force always act in what, opposite direction. So displacement and force are always what, at 180 generally, right now, opposite to each other. So work done by friction force is always negative. Then braking, when you are moving car, they apply brake force, that also what, work done by the braking force also negative, because brake we apply in opposite direction always. Okay, Body is moving that direction, the brake is applied about in opposite direction always, right? Then spring force, look here. This is the external force that we have done. Now I am talking about spring force. Suppose you are applying a force like this direction, it try to what? Stretch it. So spring force act in what? Opposite direction, kx. Spring force is called what? Kx, right now? Yes. This is the external force, that is a spring force. So if you are stretching a spring, then spring force will be in opposite direction, restoring force, so try to what? Compress it again. So when you are applying external force, you know that it will act like increasing length in that direction. Spring force always in opposite direction, so work done by spring force will what? Negative, right now? Yes. So this is a way to say what? Who is positive, who is negative work. In graph is again simple to say, positive quadrant means positive work, negative quadrant means what? Your negative work done, right? Okay. Apart from this, one theoretical thing they ask very important about this, when work becomes zero, very very important. So important point talking here, work will be zero if, what are the conditions under which work becomes what? Zero, correct na? When the work done by body will be zero. So let's first talk about this formula. First term is force. If force is zero, work done will be zero. Simply you can say, okay. If net force acting on the body, you always should say what? Net force here, right? That's really more correct word. If net force is zero, then the work done by the body will be zero. Then you say, okay, this is done. Then you say displacement, correct? If you say, if net, we don't say here net, just say displacement word only. If displacement is zero, in that case again the work done will be what? Zero, correct? Okay, this is done. Then say about angle. If theta is what? 90 degree, then cos 90 becomes what? Zero, right? So you say that if theta is equal to what? 90 degree, means the body and the force and displacement of the body are perpendicular to each other, then work done will be zero. I will give example also, correct? Okay, then let's say, because this force is nothing but what? Ma. Force is what? Mass into what? Acceleration of the body. If acceleration is zero, then again the work done becomes zero. So you say that if body moving at constant speed, you say if body moves at constant speed, right? Or simply you say that acceleration of the system is what? Zero. Then again the work done by the body will be what? Zero. Correct? Some famous example will talk where the force becomes zero. So these are four ways to make what? Your force zero, right now? Sorry, work zero, force may be zero, displacement is zero, theta may be 90 degree, or body moves at constant velocity, acceleration is what? Zero. Look here, some famous example where work is zero. One problem is this one. You have seen at railway station those load carrier, or you call them coolies, okay, helper. If they are carrying a load on their head and they are walking, correct na? Then the work done by gravitational force will be what? Zero. Why zero? Because gravity force is acting straight downward. Suppose you are carrying a suitcase on your head and they are walking horizontally, then work done by gravitational force will be zero, because gravitational force acting straight downward and they are walking horizontally. So the angle between force and displacement is what? 90 degrees. So work done by them will be zero. Means work done by gravity force is zero. There are many type of force acting, keep in mind. Okay. Yeah. So work done by gravity force will be zero. And like we talk about these, suppose some planet is revolving around a planet, right? Some satellite is revolving around a planet, or planet is revolving around what? Sun. Then the work done by gravitational force will be again what? Zero. Why? Because this is some planet, that's a satellite, okay? Yes, satellite. So you know that the displacement is what? In this direction. Okay, that direction is what? Displacement, and gravitational force and centripetal force are like in this direction. Both are perpendicular, right? Centripetal torque or gravitational torque, both are perpendicular to what? Direction of displacement. So again, work done by the centripetal force and gravitational force all will be what? Zero. Also you can say that because moving complete one circle, so net displacement also zero. So work done by the net displacement also what? Zero. Sorry, net displacement is zero here. So work done also becomes what? Zero. You can say in terms of force also. Okay, centripetal force and gravitational force, attractive like that one, okay, gravitational, that's what centripetal FC, both are what, perpendicular to the direction of displacement, right? So that angle becomes what, 90 degrees, so you can say work done will be 0, or you can say that it moves in a complete circle, so net displacement also 0, so work done will be what, 0 in case of what, a satellite moving around a planet, or a planet is moving around a sun, right? Okay, okay, so now what we will do, we will do the problems on this type of work done by constant force in vector form, by variable, right, by graph. So we will see example on all of these, right? Okay, let's see. Okay, let's see few problems. So we are doing problem based on like constant force or in vector form, okay? Yes. So see first the saying, we are talking about what, work done by a constant force, right? Here F as cos theta we have to use. Okay, let's understand. First question, they said a 20 kg body is at rest and a force of 5 Newton is applied on this, calculate the work done in first second. Okay, mass of the body given, initially at rest, and force applied is given, and we have to calculate work done in what, first second. So formula is what, work done is what, F as cos theta. They did not mention here about what angle, right? Theta is not given. When not given, then what we assume is what, they are moving in what, same direction. General case will talk, but in simple case the displacement and body are in same direction only, right? So we have to talk what, take as 0 degree, okay? Yes. Okay, angle, you understood, you have to take 0 degree, okay? Yes, general case. Force already given to you, 5 Newton. Now you have to talk about displacement. What does the displacement mean? Displacement is not given directly. They gave like what is the work done in what, first second. So mass given and what given, time given to you. You have to calculate displacement. Initially at rest, this is also given. So look here. So displacement you have to find. So you have to write equation of motion. 3 equations we have. V is equal to u plus at. Acceleration you don't know. Then second is v square minus u square is 2as. Again acceleration you don't know. And third, s is ut plus half at square, correct na? So if you use that equation, then what we will get, look here, we can calculate acceleration because force given and what, mass given, okay? So third equation we can write, look here, s is equal to what, ut plus half at square. Initial velocity is given 0 because at rest, so this term is 0, s is equal to half at square, okay, half. Acceleration means what, force by mass. Acceleration not given directly, but force and mass both are given. So acceleration become force by mass, force is given 5 Newton, mass is given 20 kg, into time square is given what, 1 second, first second, right now? Okay, so when you simplify, this becomes simply 5 by what, 40, that's all. Okay, if you want to simplify, okay, can I just write what, 1 by 8. This is what your displacement. Now you have to calculate work done. So force is again what, 5 Newton into displacement you calculated what, 1 by 8, and angle we calling cos 0. When not given, then you have to call cos 0, that's become 1. So that's your answer, how much, 5 by 8 joule. That's your what, answer, okay? Then simple question, yes. Okay, let's move to the next question. Calculate the work done raising a stone of mass 0.5 kg through a height of what, 20 centimeter. You want to take a stone from ground towards some height, correct? Na? Yes, so they are saying what is the work done by us. Here many work done they can ask, suppose they can ask what is the work done by gravity or work done by us, they are asking this question. I will explain this. Let's calculate first what is the work done, what work we have to do to raise a stone from ground to some height h. So work done is the same formula, F as cos theta, very important. Force, okay, how much force we are applying, can you see? Yes, directly force not given, but you understand that you have a mass of 0.5 kg, you are raising to some height, so we are doing against the gravity, right? Mg, gravity is what, downward, we are doing against, so we have to do work against what, gravity, right? So what is your force? Simply what, mg, displacement given and cos theta we also right? Give attention here, very important. Mass 0.5, g is what, 10, displacement that said something what, 20 centimeter, so 20 into 10 power minus 2, and what is cos theta? Here they are asking work done by us to lift a body upwards. So you have to apply a force what in upward direction to lift it, right? And displacement also in what? Same direction. So angle will be what? 0 degree. So cos 0 means what? 1. Okay. Yes. So this goes. What is the answer simply coming? So what? 1 joule, right? Sometime like I do calculation wrong, not concept. So you can put in comment that I did some calculation wrong. So I'll rectify. Okay. Yes. So 1 joule is the answer. Now it's very important. Suppose they ask that we raising a body up to that height, what's the work done by gravity? Then answer will be same only, but it's what? Negative. Because they ask what's the work done by gravity? You are lifting body upward, your displacement in that direction, but gravity force is what? Downward, mg again, right? Now same force only. So this angle will be what? Cos 180. Displacement upward, you are taking a body upward, and gravitational force is what? Downward, right? So this is an example I already gave there. Listen carefully. Suppose freely falling, a body is freely falling like this one. Then this is the direction of force mg downward, displacement also downward, right? So then work done by gravity will be what? Positive work. But if you taking a body upward, then they ask what is that? This is direction of displacement, rising upward. Mg is what? Acting downward, gravitational force, right? In that case, the work done by gravitational force will be what? Negative. But in this question, what they have asked? Work done by us. We want to lift a body. What is the work done by us? You want to lift and you have to apply force what? Upward only. So force and displacement in the same direction. So work done by us will be what? Positive. That's this question. Okay. But gravity you have understood that if body is falling downward, the work done by gravitational force is positive, or body is rising upward, then work done by gravity will be what? Negative. Okay. Yes. Okay, let's move. Next point. Okay, done this. Now, this is a very important question. All possibilities are here. Let's see them. So, look at the question number what? 3. Okay. Question number 3 says, a 10 kg block is placed on a rough smooth surface. Okay. Here I forget to draw a picture. I can draw it again, no problem. So, this is a picture here. Anything you can write. So they said this is a 10 kg body is placed on a surface. Let's surface was rough. You can take a rough means frictional force is there. Let's write 0.4 anything. Okay. And some force is applied on this. Let's say how much? 20 Newton. Okay. Yes. Okay. Now calculate the work done by gravitational force, by normal reaction, by the applied force, and by frictional force. 4 forces are there, and we have to calculate the work done by due to these 4 forces in displacing this body by what? 5 meter displacement given, and we have to calculate work done by this. So let me redraw this picture more clearly. Let's write all forces acting on this body. We are applying a force on this, that's called your applied force F, that's given 20 Newton. This surface is rough, so friction is there, and mu is given 0.4 to u. You know the frictional force will act in that direction, that's a frictional force. Correct? Frictional force, that's applied force, body is moving that's the direction of displacement, right? And normal reaction will be upward, and weight will be what? Downward mg. Clear? These are the 4 forces acting on this body, and we have to calculate what is the work done by these 4 forces. So let's do one by one. First you talk about what? Your gravity. Work done by what? I am writing shortcut, you write properly. Work done by gravity force is what? Force work done is what? F dot s into cos theta, right? Gravity, what is gravitational force? mg. Displacement given as something given, but what is important here? Angle. Body is moving horizontally, and gravitational force acting what? Vertically. So angle between displacement and your mg is what? 90 degree. Cos 90 you put here, your answer becomes directly what? 0. So work done by gravitational force is what? 0 on this body. Correct now? Yes. Same way, let's talk about what is the work done by normal reaction. What is the work done by normal reaction? That's the normal reaction. So you see normal, what's the value of normal reaction? N will be equal to simply mg in this case. That is equal to that, that is equal to that, right? Yeah. So what is the work done by gravity? Same form, right? Work done is equal to Fs cos theta. Gravitational force values again mg, or you can put n also if it is known to you, no problem. And displacement is given to you. Again cos is what? Again cos is what? 90. Because this normal reaction is upward and body is moving what? Horizontal. Displacement is what? Horizontal. So again this work done also becomes what? 0. So work done by gravity force, work done by normal reaction is 0, because these forces are perpendicular to what? The displacement of the body. Okay, let's talk about now next third is by applied force. Okay, work done by applied force we are calculating. This is the force. So work done will be Fs cos theta again. This force in that direction, displacement in that direction. So force is 20 Newton, displacement is given 5, and cos what 0 degree. Cos 0 means what 1. This applied force and displacement are in the same direction. So angle is 0 degree. So that becomes 20 into 5. That becomes what 100 joule. Correct? Yes. Okay. Last, what is the work done by frictional force? We have to calculate what is work done by frictional force. So first you have to calculate value of frictional force, right? Okay. So look here. What is the value of frictional force? In this, you can write F. Okay. So look, F is equal to what? Mu into what? N we know, right? And mu mg, right? These things. So you can write same formula we writing. W is equal to Fs cos theta, right? Frictional force is how much? Mu mg, mu into n, n is what? Mg. Mu is given 0.4, mg means this was 10 kg body, right? 10 into 10, displacement is given 4, and cos theta, the angle between displacement and the force. This force in that direction, displacement in that direction, so that angle is what? 180 degree, and cos 180 means becomes minus 1, right? So this work will become negative, yes. So look here, okay, this becomes 4. And 4 into 4 is what? 16. So 160 minus 160 what? Newton. Sorry, not Newton. We are talking about what work. So we write joule here, right? That's the unit. That's the work done by what? This. Okay. Hope you understood this. There is no big problem. Correct? Yes. So work done by different type of forces depends upon what angle and their values. Okay, now second we finding the work done by constant force in terms of what? Vector form. Vector form is given, then what we do. So look here, first question, calculate the work done by some force given vector form in carrying a body from point here to what? That point, right? So here you have to write vector form. Vector form work is what? Simply F vector dot S vector, right? F is given directly. Now write displacement. Let's write what is displacement. S is what? We are moving from this point to that point. So always final minus initial you have to do. Okay, x coordinate is what? Final 3, this initial minus 2. 3 minus minus 2, right? That becomes 5. So I write here what? 5i. Then 6 minus 1. That becomes what? 5j. Then minus 2. Then minus 3 becomes what? Minus 5 what? K. That's a displacement, right? Okay, now you have to multiply what? Work done is what? F dot S. Force is given 3i minus 2j plus 4k. This is what your force multiplied with 5i plus 5j minus 5k. Right? So in dot product very simple, only same thing becomes 1, like I dot I is what? 1, remaining all are 0. So look here, 3i and 5i. 3 into 5 is what? 15. So that becomes what? 15. I dot I is 1. Other you don't need to multiply because 3i into 5j becomes 0, 3i into this also becomes 0. Okay. So directly 2j into here with j multiply 2j and 5j, right? So this becomes what? Minus 10. Same way k, 4k and what here? Minus 5. That becomes what? Minus 20. 4 into what? 5. K into k is what? 1. So that becomes minus 20, right? Correct? Okay. So look here, this become how much? 15 goes here. So answer is coming what? Minus 15 what? Joule. What's the meaning of negative sign? That body is moving in a direction opposite to what? The force applied, right? No? Yes. So work done by that force will be what? Negative. Okay. Let's see next question. This question, they said two force, one for this, one for this, are acting simultaneously on a body and displacing from position vector r1 to what? R2 this vector. What is work done? 2 force acting, 3 force acting. You have to first write what? Net force. In this formula F is what? Net force only, right? Okay. So what is total force? Let's find net force directly. I'm finding what is net force acting on the body. You have to add these two forces F1 and F2, right? 2i plus i, that becomes what? 3i. Then 3j and minus 2j, that becomes what? J. Then minus k and plus 3k means plus 2k. That's the net force. Okay. Now find displacement. What is displacement? We are displacing from this point to that point. Like here coordinates given, here directly vector form are given, same thing only, no big problem. Final minus initial, okay. Okay, 5i minus 3i means what? This is what? 2i, okay. Minus j minus 2j, that becomes minus 3j, 3k minus k, that becomes what? 2k. So that's your position vector, right now? Okay, so you have to take dot product of these two only. So I am doing directly. Work done is what? F dot what? S, right? Okay, 3i into 2i, that becomes what? 6. J into minus 3j, that becomes minus 3. 2k into 2k is what? That becomes what? 4. Other things become 0, so you no need to multiply, right? Okay, so this becomes 3 and plus 4 means what? 7 joule. Also you have to give attention here. When write like here, what is unit given? Newton given SI system, and here what is given? They should write like meter or centimeter. Suppose meter written, like here I wrote here meter, right? Meter. So you have to give attention. Suppose this is given centimeter, then be careful that here you write in meter at the end, like very dot. Suppose this is displacement. Suppose this was given in centimeter, what? Displacement. Suppose I write centimeter here, right? Both. Then at the end you have to multiply like 10 power minus 2 to convert it into meter. So answer will not become 15. 15 into 10 power minus 2 means 0.15 answer will come, okay. So you have to give attention to what? Unit also, okay, because in vector form people confuse here, they don't give attention to unit here, okay. So focus on unit, what is unit given, right? So these are the questions on what? Vector form and constant force. Now we will do on what? Work done by what? Variable force, okay. Okay, so now we seeing some questions based on what? Work done under a variable force, and that calculating work done by calculating the area of under what? Force and displacement curve. So look first variable force example. Calculate the work done by this force. Force is given 3x square plus 10x minus 20 in displacing body from x is equal to 0 to what? X is equal to what? 3 meter, or some coordinate is also given, no problem, right? So this is simple question. One variable is given, x is a variable, right? So you write your formula that work done by variable force is what? F dot dx, x1 to what? x2. Yes, let's put force. What is force given? 3x square plus 10x minus 20 into dx, range given 0 to what? 3. We are displacing from 0 to what? 3. Okay, integration of this is what? Integration of this simply becomes how much? 3x square becomes 3x cube by 3, right? Hope you know integration. Integration formula is what? Basic integration, x power n into dx is what? X power n plus 1 by n plus 1, right? That power is increased by 1, then power you write down also. 10x, that becomes 10x square by what? 2 minus 20x, 0 to what? 3. So work done will be what? First you can simplify this, this goes here, this goes 5 times, right? Then when you put everywhere is x, when you put 0, everything is what? X. Directly put 3. Okay, cube, that becomes 27 plus, then here is what? 9 into 5, that becomes what? 45, then 20 into 3, that becomes what? 60, correct? Minus 60, okay. So 27 and 15, 7 plus 5, so how much that comes? 12, 72 minus 60, this means what? 12 joule is the work done in this process, okay. So this is a simple integration type of question, and in exam they ask like this way also, very very simple. The vector form has been asked many times, and this type also question has they asked. This is what is single variable, only x is a variable. Now look at next question. I said about the Cartesian form when multiple variables are there. So the variable force acting body is given by this 6x square I, 3y square z and plus 2z into k. Calculate a work done displacing body from this coordinate to that coordinate, okay. So in multiple variables you write Cartesian form, how you write that? Work done is equal to first force in x direction into what? Dx, then force in y direction into what? Dy, force in z direction into what? Dz. Let's put the value. What's the force in x direction? That's the force in x direction, 6x square, 6x square into dx, and limit also you can put range. X varies from 0 to what? Minus 2, 0 to minus 2, Then force in y direction, that's given what? Minus 3y square into what? dy, and limit is given 1 to what? 1 to what? 1. Okay, then force in what? z direction, that's given what? 2z. So 2z into dz, and range is given 0 to what? It's looking too much, many become 0, I'm changing little. If you want to keep same also, okay, doesn't matter. It varies from 1 to what? 0, 1 to what? 0, no problem, okay. Okay, when you integrate this, what you will get? I'm doing on this side. So 6x square, that becomes 6x cube by what? 3, that becomes simply 2x cube, correct na? 6x square, x cube by 3, 3 get cancelled here, okay. Limit is given 0 to minus 2, I put in next step. Okay, 3y square, so it becomes 3y cube by 3, so that becomes simply minus y cube and 1 to 1 plus 2z, that becomes 2z square by 2, that becomes simply z square 1 to what? 0. So when you put all these values, what we will getting is this. When you put 0, it becomes 0, right? When you put minus 2, we can look here, this becomes minus 8 into 2, that becomes minus 16. Okay, let's talk about here. You put 1, already 0, this term is what? 0, and when you put 0 becomes 0, then you putting 1, 0 we putting 0 here becomes 0, then minus we putting this limit, so it becomes what? Minus 1. It becomes answer is coming minus 17 joule. That's the work done in what? That variable force. So single thing is varying, like x coordinate only given, or like x, y, z all are given. You can write Cartesian form like that way. So these are the question on what? Variable force, means you have to do integration. Okay. Now we are talking about the fourth format, where they gives the area and we have to calculate work done by the area, right? So look at this question. Calculate the work done moving from x is equal to 0 to x is equal to 15. 0 to 15 you want to move. What is the work done by this body? So body is moving, this is a graph given somewhere like this, okay? Yes. So simply we have to calculate area under the curve, right? Okay. So watch it here, 0 to 6. This is looking like a rectangle, this curve, right? So calculate the area of this rectangle. What's the area of this rectangle? Length into breadth, 0 to 6. So it becomes 6 minus 0 means 6 only. Height 0 to what? 10 given, 10. That becomes 60 joule, okay. Let's calculate area of this small triangle. That is triangle here, you can see, right? Triangle area is what? Half b into h. Half, base means 6 to 8. That becomes what? 2. 8 minus 6. Height is what? 0 to 10 means what? 10. So that becomes what? 10 joule. Okay, then this triangle in negative side, right? Okay, so same formula, half base into height. Half, base means what? 8 to 15. So 15 minus 8 means 7. Height is 0 to what? How much? Minus 6. So you write 6 or minus 6, doesn't matter, 6. That becomes 3. 21, but you will write minus 21 joule, because this is what in negative quadrant, so work done will be negative. So what is net work done in this? That becomes, here we got 60 plus 10 minus 21, 70 minus 21. So that becomes what? 49 joule. That's the work done in this graph, right? So any shape of curve is given, just you have to calculate area under the curve. Positive quadrant means positive work, negative quadrant means what? Negative work simply. Let me give one more example like this, okay, here. Suppose I ask you to calculate the work done in this process, right? And I give a picture like this way. This is just for practice. Okay, this is the question, and we have to calculate area. We have to calculate work done. So this side is the force. That's force. This is given 20 Newton. Let's say here 10 Newton. And this side is what? Displacement in meters. You have to give attention again here. This displacement. What is unit? Sometimes they write centimeter, then the answer will not be this 49 joule. So answer will be displacement. You write what in what? Our meter system. So into 10 power minus 2 will come when write in meter. If centimeter is given here, right? So you have to give attention what is unit given here. That's very important. Okay, so the curve is given like that way, and we have to calculate that what is the net work done in this cycle, right? Okay, so this is 20 Newton here, 10 Newton I said, 0 to 4, 8 and 12, okay. This is what meter. These are the distance in meter. So you have to calculate. So you can pause this video and first you calculate the answer of this question, then you see it, okay. So I am waiting for you. Okay, hope you have done already this. So let's check your answer. So you have to calculate area. So look at, I have divided this into two parts, a rectangle plus a triangle, right? Whole is a trapezium. If you want to calculate, you can calculate, your choice. So this is a triangle. Let's calculate area of this triangle. Half into base into height. Half. Base means what? This much. Means 0 to 4. Means 4. Height means what? 10 to what? 20. So what? 10. 20 minus 10. That much height. Okay. Okay. So this become what? 20 joule positive. Okay. Then this rectangle. Let's calculate. What's the area of this? 0 to 4 and 0 to 10. So 4 into 10 means what? 40 joule. Let's calculate area of this rectangle. 4 to 8 means what? 4. And 0 to again what? 10. So this is also 10. This become 40 joule. Correct. Then talk about this. Okay, here I missed one thing. I should give the force in negative direct like this one. So let me write here some 8 Newton. Okay. Something. Okay. Calculate area of this. So what again? Triangle, half b into h, half base means 8 to 12 means what? 4, right? And this is given what? 8. So this becomes 2. That becomes minus 16 joule. We'll write negative because what? Negative quadrant. So work done this will be what? That's 20 plus 40 plus 40 and minus what? 16. 40, 40, 80, that becomes 100, 100 minus what? 16. So that becomes what? 84 joule, right? So these are the questions based on what? The very basic first starting topic, that's called just work alone, okay? So work you can write in 4 ways I have done, like work, force can be constant, then you have to calculate work, then this force and displacement can give in vector form, then you have to calculate work, then it can be variable again 2 possibilities like single variable or what? Multiple, right? And then last is what? Your in terms of what? Area under what? Force and displacement curve gives what? Work, right? Okay.